everyone. Today we're going to be discussing the rational root theorem. So the rational root theorem is used to find the possible rational roots of a polynomial. So up until this time, I've given you one of the factors and I've asked you to find the roots of the polynomial. I was being nice. Now, sorry, we're taking off the training rails. No more Miss Nice Fig. We're going to go ahead and test out all of the possible rational roots of a polynomial in order to figure out which ones are the actual roots. This is going to be kind of a long and tedious process. I'm going to try to show you any shortcuts where I can, but let's get to it and you see our first example. So in order to find the possible rational roots, we are going to take the last term, the constant term, and then find all of its possible factors. We're going to divide those possible factors then by all of the possible factors of the leading coefficient. So if we take a look at our first example, right, y equals 2x cubed plus 3x minus 5. We have a constant term of 5. So its factors are plus and minus 1 and 5. The leading coefficient is 2. It has factors of, again, plus or minus 1 and 2. So we have our setup down below here that all of our possible rational roots can be rewritten as plus or minus 1, 5. And then 1, 2. So what does that mean exactly? Let's write out all the possibilities that we are going to have to test here. So if I divide 1 by 1, that's a possible rational root of 1. If I divide 1 by 2, that's another possible rational root. Okay, let's scooch over now to the 5. 5 over 1 is a possible rational root, and 5 over 2 is a possible rational root. So remember, these 4 options here are actually 8 possibilities because we have to test both the positive and the negative option. So we have 8 numbers that we're going to test here. Keep in mind, we don't have to test all 8. Sometimes we will, sometimes we won't. We know at most, because we're looking at a cubic here, at most we will have 3 roots to our polynomial. So if we start testing and we find 3, we know we're officially done. We've hit the max. All right, so let's take a look at our examples and let's start testing. We've gone over synthetic division and synthetic substitution. Whichever method you prefer is completely fine here. And if you have your graphing calculator handy, I'll show you how to do a shortcut on there as well. So let's say that we test 1 and we choose to use synthetic division. So that means I'm going to bring down my 2. I'm going to multiply and add and multiply and add, multiply and add. And hey, I'm lucky right now. I know that x equals 1 is one of our rational roots because I have 0 as a remainder. All right, so I'm going to go ahead and I can keep testing. I can test -1 and see if that works. So -2 is -2, which is +4 and 7. At this point, I'm not even going to bother, excuse me, with the last step because I already know when I multiply 7 times -1, there is no way that that is going to cancel out with that -5. So I know that it's not going to cancel and get a 0 for a remainder. I don't even bother. I keep going and keep looking at the different options. So a little cheat on the calculator. All right, if we're going to be using a synthetic substitution for this method, let's take a look at storing our options. So let's say that I store that 1. So 1, store x, enter. We get our confirmation. And now we start writing in our equation. 2x cubed plus 3x minus 5. When we hit enter, we again get that same confirmation as before, though we got 0 as a remainder, so we know that 1 is a root. All right, say we wanted to plug in -1 then. Store that as x. Okay, this is where the cheat comes in. Normally you have to retype your equation. Yeah, I don't have time for that. I really don't. So I'm going to use my calculator to highlight from before our equation and just hit enter. That -10 is going to be the exact same -10 that I would have gotten if I finished my, if I finished my long division and, if I did it correctly the first time. Did anybody else catch my error? So this was actually going to be negative 2. So this is going to be a negative 2. This is going to be a positive 2, which is a 5. And then this is a negative 5, which gets us to the negative 10. So that same negative 10 is the same negative 10 that I got up here. So I can just keep going through. 0.5, store x, enter, re-highlight my equation, enter, and try to figure out which ones that work. I'll save you guys here. I know that there's only one possible rational root here. So as long as I keep checking, nothing else is going to work. How do I know that there's only one possible root? Well, I took a look at the graph from before of our function, and I saw that it only crosses the x-intercept once at 1, 0, which again confirms what we had gotten for our x-intercept. All right, so I'm going to give you a second equation now. I want you to pause the video, take a look at the possible rational roots. Just do that step first. See if you can write out all the possibilities, and then we'll try again to solve. All right, go ahead and hit pause. All right, possible rational roots. Plus or minus, we got to look at the factors of our constant term. So factors of 12 are 1, 2, 3 goes in, 4 goes in, 6 goes in, and 12 goes in. All right, and then the factors, thankfully, our denominator here is just 1. Only factor of 1 is 1. So we have 1, 2, 3, 4, 5, 6 plus or minus. So we have 12 different options to test. So we'll go ahead, your choice, synthetic division or synthetic substitution. Go ahead and use whatever cheats you want from the calculator. I'm actually going to scooch straight to that calculator. Let's clear this out. Let's test 1. I'm going to store that as my x. And let's type in our equation. All right, 1, hey, I lucked out with 1 on both times, so 1 is definitely going to be a factor. Now, if I divide this full equation by 1, that gets me down to a cubic, so that's at least helpful. It's bringing me down to a quadratic. So I'm going to actually do that long division here. Let's see, we're definitely going to need more space.